Good morning, everyone. We are ELECOMP Team TACO Comfort Solutions. My name is Christopher Volsi, and I, along with Paul Crisafoli, are the electrical engineers on this team. And Timothy Boyd is double majoring in electrical and computer engineering. And we'd like to present to you our capstone design project, a voltage to PWM converter. Now, for those of you who are wondering, what exactly is a PWM? PWM stands for Pulse Width Modulation. Now, the most simplest definition we can provide for you is that a PWM is a square wave signal which modulates its pulse width in order to communicate information. There are various applications of a PWM, such as audio amplifiers, DC electric motors at high frequencies, and power supplies. But for our context, in particular for TACO's context, it's using heating elements. Heating elements such as pumps, boilers, and various ventilation systems. Now, let us get into the project motivation. TACO currently sells a standalone pump, which is capable of external control via digital PWM input. However, TACO's primary market uses an analog control scheme. Thus, we have a discrepancy between the buyer and the seller. Now, in order to solve this discrepancy, TACO has assigned us with the major responsibility to develop a controller which is capable of converting an analog control scheme to a digital control scheme. As you can see by the presentation. So, yes, converting to a digital control scheme, excuse me. So TACO currently has a standalone pump which it wants to introduce into a brand new market. However, it is imperative that our project is successful in order for them to enter this brand new market. So moving forward, here is Tim to discuss the specifics of this project.
Great. Thank you, Chris. So as we said, project motivation, we would now like to discuss the details of the anticipated best outcome for the project. As it was presented to us, we were to design a single-way analog voltage to pulse width modulation converter, which would be housed on a PCB for production and manufacturing purposes, and would contain a wall wart input to allow for DC power of the device. But we as a team decided that there was more we could do with this project. There was more potential for it. So we took the initiative and we expanded our anticipated best outcome as follows. Rather than do a single-way translation between analog voltage and PWM, we decided to do two ways, doing the translation backwards as well, which presented other challenges like capture of PWM signals and the generation of 10 volts by a microcontroller, which is typically not possible. Furthermore, we wanted this PCB that we would design for it to fit an existing TACO enclosure, which would obviously save money on the production of a new mold and would, in general, simplify the design process. Furthermore, we wanted to be able to power this device not only with DC voltage, but also with analog voltage. And furthermore, we wanted to have power on safety diagnostics similar to those found in IEC 60730 Class B, which has to do with the testing of the power on safety of the device, if it is ready to work when it turns on, and whether or not it's safe to proceed. Even further, we wanted to implement production line testing capability so that the manufacturers and producers on the production line could ensure that every single device that is left the facility works as expected, which also involved us modifying an existing TACO design tool, the GUI, for their actual production line testing. And the goal was to still have this ready for in-lab alpha testing by the end of the year. Now let's talk about what got done. We started by selecting the processor, which is a very important step in this process. It needs to do exactly what we need it to do. It needs to have all the capabilities that are necessary for performing the conversion. Furthermore, we designed the power to allow the device to take both the DC and the AC power inputs, as well as the hardware that would enable the device to communicate with its environment, the capture of the PWM, and the generation of 10-volt signals. An important step. We also involved the connection with the production line testing terminal for the production line testing capability, and finally housed this whole thing on a 1-inch by 1.5-inch PCB, which is already sitting on our demo table out there. On the firmware side of things, we started by enabling the two-way conversion between analog voltage, and PWM. This being the important baseline step in achieving the project motivation. Furthermore, we enable the communication with the production line testing terminal over a USB to UART interface and enabled power on Class B safety diagnostics for the testing of the device, as mentioned, to make sure that every single one that turns on, when it turns on, is ready to work exactly as expected. And even further, we implemented TACO's proprietary packet-based CRC-protected protocol for the production line testing. Now I'm going to give it back to Paul because, as you can see, we have achieved not only the two-way conversion, we've also achieved the power. We've built the PCB, we have the power on safety diagnostics, and we have the production line testing, meaning that in no short words, we have already achieved our anticipated best outcome for the entire year in a semester.
So as you've just seen, we've already met our best anticipated outcome. So what's next for us? So we're going to start by implementing hardware to support NFC wireless technology. This is already on the boards that we've had made up. This will allow wireless data transfer and wireless mode switching of the device. To go along with enhanced capabilities, we're upgrading the processor to have cleaner output signals. And to go along with the processor, we're developing a bootloader to allow firmware updates later on wirelessly via NFC by the end user. Additionally, we're developing software tools to aid in the design process. What does this mean for TACO? Well, it means that we've designed this device, which is capable of the conversion that they desired, so that they can enter the market and see up to $400,000 increased annual revenue. But more than that, we've packed a whole lot of punch in a really small device that is still cost optimized and stays in the pre-existing enclosure. At the end of the day, we were given this project, one-way analog to digital conversion, and we will deliver at the end of the year this project, which is capable of so much more and has been designed in a modular way so that TACO can use these components in future TACO products and any revisions of TACO products for wireless NFC or the new TACO GUI that has been modified. This comes from us, Team TACO, because we know that the future is not just fast approaching, it's here. We'd like to thank everybody who's helped us along the way.